Everyone, welcome to number system 4. So we have done 3 more videos before on this topic. My name is Prashant Mohan Thakur and you are on Competition Valley. So as we have been doing, so we'll be continuing the same thing. Today we'll be picking up some new concept and methods. So let's begin. So let's try to find, okay, let's look at these numbers and try to observe something from this number. Let's say 4, 6, 8, 9, 10, 12, 14, or we can take 18, 15, 25, like 100, 81, anything. Now what we're trying to do over here, look. So what would be all the factors of the number 4? It would be 1, 2, and 4. For 6, 1, 2, 3, and 6. For 8, 1, 2, 4, and 8. For 9, 1, 3, 9. 1, 2, 5. And let's do for some big numbers. 1, 2, 4, 5, 10, 20, 25, 50, and 100. And for the same 81, 1, 3, 9, 27, 81. Now these are normal factors. When we talk about factors, there are two things we should consider. One is normal factor, what is, you can say, multiple division, and then the other should be prime factor. Okay, so we'll be covering both of these things today. Okay, and we'll understand the difference between each of these one. So now these, what we are these are called normal factors, wherein we are just splitting up the numbers. Okay, we can see odd, even, everything is mentioned over here. Now what we are trying to do, so these are some of the factors. So what if we try to convert these factors into a prime base sort of thing, if we try to do that? Okay, so let's say 4 has 3 factors, isn't it? So 4 has 3 factors. So can we write 2 to the power 3? Because 4 has 3 factors. But if we write, so now this is a purpose. I know it's going to be 2 square, but I've written it purposely because I want to show you something. So even though it has 2 factors, we cannot write it like this, because if you write like this, it means we are not getting the right number. So what should we write? So can we write 4 as 2 to the power 2? Now observe what I'm trying to tell you. The power is 2 and the factor is 3. Okay, got it? Power. The same thing we can try for, let's say, we can try here for 8. 8 has 4 factors. Okay, so if we write 8 over here like this, so what would it mean? That it has 3 power is 3, but the factor is 4. Similarly over here as well, we can write 2 as 2 to the power 2 into 5 to the power 2. Okay, so yes, so you see over here that these are the power. So how many factors it should have? 3 into 3 equal to 9. It would not have 4 factors, it would have 9 factors. You can count it: 3, 3, 6, and 3, 9. Similarly, if we want to write 6, we can write 2 into 3. Now what do we see over here? That 2 has power 1 and 3 has power 1. So how many factors would we have? 2 into 2 equal to 4. See, yeah, 4 factor. Any number you can take 12. So 12 will be 2 into 3 into 2. So it should be 2 square into 3 again. So the number of factors should be 3 into 2 equal to 6. So what we are trying to do over here, now I'll just try to generalize that fact. Generalization, if I do, let's say I take, let's say 4 for example, 4, and we know 4 is 2 to the power 2. Okay, so when we are writing 2 to the power 2, isn't it something like this would happen? 2 to the power 0, 2 to the power 1, 2 to the power 2. These would be the factors, isn't it? 1, 2 and 4. Similarly, when we are writing, let's say 100, so it is 2 to the power 2 into 5 to the power square. So how we can write 2 to the power 2 is 2 to the power 0, 2 to the power 1, 2 to the power 2, and again 5 to the power 0, 5 to the 1, 5. Now what we are doing right now here is we are breaking this into prime bases. These are prime bases. Okay, all these numbers are prime bases, what we're trying to do. And what this gives us, okay, what this gives us is that we can find the factors of any number using this generalization. So what we can do from here is, let's try to create an identity over here. So can we imagine something like this, that if there is a number with p to the power a, provided p is a prime number, then the numbers of factors of p would be a plus 1. Can we think of something like this? Now we can extend this assumption again, that if there is a number, let's say p a into q b, then what would be the factor? Then the factor would be a plus 1 and b plus 1, isn't it? Again, if you want, we can further extend this over here. Let's assume there's a number pa into q to the power b into r to the power c. Then can we write all the factors as a plus 1, b plus 1, c plus 1? Think for a moment. We can keep doing it. We can do it for any number. So what we get, that we can derive total factor from breaking a number into its prime base, because number of factors would be power plus 1. That's all. Okay, I hope you would have got it. So let me do some questions so that it is further easier for you to understand this. So find the factors for following. We can take 82, take 146, take 152, we can take 900. Let's start with these 4 first. So 82 should be 2 into 41, and we know that 41 is a prime number. So what the number of factors? Look, 2 has power 1 and 48 has power 1. So we know that if p has power 1 and q has power b, like p has power a and q has power b, where p and q both are prime numbers, then the total number of factors would be a plus 1 into b plus 1. So if we take p this and we q this, then our would be 1 plus 1, 1 plus 1, which should be 4, isn't it? Let's do the second one. 1 into 46. So we do it 2, so it should be 7, and 7 is 10, so it should be okay. So we can understand again, p into q power a, so would it be 1 plus 1 or 1 plus 1? Power should be 4. We can do this for 152, it should be 2 into 76, or 2 into 2 into 38, or 2 into 2 into 2 into 19. So what do we have? We have 2 cubed to 19. So can we do this way then? Then the total number of factors, can we consider them as 4 into 2 equal to 8? Now how we are getting 8? It's very simple. 3 plus 1 and 19 plus 1. We have studied how and why does this grow by 1 when we are doing the full factor. We have already studied this before as well. And if you want, we can do this for 900 as well. We can break 900 into, this is what it would be, 9, and this is 25 and 400. So how much it would be? It would be 2 plus 1, it would be 2 plus 1, it would be 2 plus 1 equal to 8. Isn't it? Look over here. Any doubt? Just we have used this form. If P has power A, Q has power B, R has power C, then the total number of factor would be A plus 1, B plus 1, and C plus 1. That's simple. Very simple, isn't it? Okay. Now let's do another question. Okay. You can take let number n be as such that it has 4 factors and the number is the only even prime number. Okay, again, let a number n be as such that it has 4 factors and the number is the only even prime number. Okay, so what is the sum of all the factors of n? Okay, now just read the question once. Okay, it's an early stage, so just read it once more and try to attempt it, see how far you can go. It may look difficult, but it exactly isn't. It's completely based on the concept of prime number and what we have tried deriving, how we can derive a factor out of it. Okay, so n is a number such that it has 4 factors. So what would be our instinct? Our instinct at n is something like n to the power 4. And what we need to find? We need to find all the sum of the factors. Now, our instinct would be this. But think for a moment, if we do this, it means that n has, we can write n0, n1, n2, n3, and n4, which would mean that n, what we are deriving from here, has 5 factors, which does not match with the requirement of the question. So certainly we'll have to take a step back, and it has to be n3, so that if we write it over here in such a if we try to break it, so it will be in this manner. Exactly, we have studied this before, that if a is to the power x, then number of factors is x plus 1. Now similarly, if number of factors is x, then our would be x minus 1. Now these are equal identities. I'm just bifurcating it. Read over here. We have already studied that there's a number with a power x, so the number of factors would be x plus 1 on the x plus 1, the total number of factors what we would have. Now if we just reverse it, over here we have gone from number to factor. If we do factor to number, what would we see? We see that number of factor is x, then the power would be x minus 1, isn't it? So see over here, so we have n to the power, we have been given 4 factors, number of factors is 4, then the power would be n3, simple. Now the second condition it gives is that the number is only even prime number. So you all know that 2 is the only even prime number, so we can take 2, 3. Now what we have to take sum of all the number of n, sum of all the factors of n. So we know 2 to 0, 2 1, 2 square, 2 cube, you can 8 plus 4 plus 2 plus 1, which gives us 3 plus 4 7 plus 8 15. Now just go through it again. Simple step. We have studied any number with the power, any prime number especially with a power x, it would have a factor x plus 1. That's the number of factor it would have. And you can check this as well. We have number 8. So 1, 2, 4 and 8. We have power 3. So this proves the given identity. So if we reverse it, if now over here we have gone from number and we checked the factors. What we have done, can we go back as well? Over here we had the factor and we need to find the number. So just a step back and we got this answer. Okay, but even if you have not understood it, so you can again straight away write an email to me. My email would be in the description. Okay, so let's do another question. Okay. 2x plus 3y plus 5z is 240,000. So x plus y plus z. Find x plus y. It's exactly the same question what we did before. Over there we had a number with 3 factors and we wanted to get the sum of all the factors. Exactly, we have to do this. It's nearby that. Okay, this question as well. So again we have 2400. So we can write it over here as 2 to the power, okay, let me simplify it first. 8 into 3, this is 24, and then we have 1000. So we can write it as 2 cube into 3 into 100 into 100. So we have 2 squared into 5 squared to the whole square, which gives us 2 to the power 4 plus 3, 7 into 3 into 5 to the power 4. And this is what we have. 336. This is the prime factor, you can say. Okay, so now we have very simple that x, or let me write it in another manner, 2x plus 3y plus 5z equal to 27 plus 31 plus 5 4. So what we can over here, even if we cancel it over here, so we have x equal to 7, y equal to 1 and z equal to 4. So the total should be, this is what being asked, so it's 12. This is our answer. Okay, again see, basic, it's all basic concept, and this is a question that has been asked in CAT as well. So see, this is as easy. If you practice this, you could have done it simply, you know, you would not have to do all these longer steps. You can simply in one step find this, and less than, it should take 3 seconds and this question would be done. Okay, so now we'll be doing another question. Let's see. Okay, again it would have some concepts included in that. Okay. Okay, let's say if an integer is divisible by 8 and 15, then it also must be divisible by 1 of the following. So we can take, let's say 16, we can take 24, 32, 45 and 36. Again, this question completely looks like the concepts would be from divisible and remainder, which is another topic which certainly I would be going through, but it isn't. It can be done just by using prime factorization as well. How? See again. Again, an integer is divisible by 8 and 15. So how do we write 8? This is. And how do we write 15? It's 3 into 5. Okay. So it says that it should be divisible by one of the following. So we have to go case by case. So if we write 16, we have 2 to the power 4. Okay. So now it says that it has to be, let's say any integer, it has to be divisible by one of the following. It means it would have components from 8 and 15, and it would have component of that number as well. So in 16 you see we have component of 8, which is 2 cube, but we don't have a 3 or a 5. So this is something, it's not going to happen because it does not have a 3 or 5, isn't it? That's the first option. Second, we have option as 24. So 24, again we'll write it. So it is 2 cube into 3. Okay, now again understand one more thing. Now let's say we want to check, let's say if a number is divided by, if a number is a multiple of 15 or not. So if we find that 3 is a multiple, we need not to check for the 5 as well, because we all know that 3 of course would 3 and 5 would be 15. So even if we can check one part, even if we get one, it would certainly means that the other would also fulfill the criteria. So over here what we have is, we see over here that we have 2 cube from this part and we have 3 from this. If you have 3 from this, certainly it would mean that it will go for 5 as well. So 24 would fulfill the criteria. Now we can check, we should always check the solution. Whatever is being taught, try to check that. Might be there can be an error from my end as well. Human, prone to error. So you can always check that. So let's say we can check for any number 122. It is done by 15, by 8. So it will be done by 24 as well. So any other number you may say, let's say we can do for 240, again it will be done. So any number you will see this which will be divisible by 8 and 15, it must be, there can be many other numbers as well, but it says it also must be divisible. So we can be very sure about this part 24, and this you can take as a concept as well, that if an integer is divisible by 8 and 15, it would be divisible by 24 as well. So you can take this as an identity as well. Okay, so these are some of the questions that we have tried doing. If you want, we can do another question. Let's see. Okay, so let's say we can try find the factors of 999. So simple, 3 into 3, 3, 3, or 3 into 3 into 1, 1, 1, or 3 into 3 into 3 into 3, 3, 9, 37. So what do we have? 3 cube into 37, or it will be 4 into 2 equal to 8. Okay, so I hope this concept is very much clear. In our next video, which would be number system 5, we would have done some more questions that would be out of these concept, but slightly molded to meet the standards of different examinations. So in this particularly, we have understood the basics of number factors and how we can derive in different ways, in different forms, the factors of a number, and how we can apply them as an application. Okay, so I hope you would have learned something new. So we'll be continuing the same thing in our next class, that would be number system 5. So till then, you can revise this video and you can go for watching all those previous videos as well. Thank you so much for your time. My name is Prashant Mohan Thakur, and you were on Competition Valley. You have a great day.